Hello everyone and welcome back to Skimonicus, and we're back live with another live streaming again. So I'll just wait for some people right here and let the charts begin so we could have a discussion on physics and mathematics. All right. Techno coders, hi bro, hi. Ayan Unfiltered, assalamu alaikum, walaikum assalam. Zahir Hussain, assalamu alaikum, bhai, walaikum assalam. Tahir Mirza, hello, hello. Raza Neat, assalamu alaikum, Sarim bhai, walaikum assalam. And Ved Prakash Dev, hi, hi. Rishu, hi, hi. Unfiltered भाई question है भाई आपसे well sure you can ask. That's what we are here for. Tahir Mirza, कैसे हो? Well, I'm doing good. Techno coders remember me for sorry for leaving DC without telling you. Well, yeah, of course I do. Ved Prakash Dev, how to understand physics? Now, that is one question I have answered many times. So, if there's different varieties to the question, you can basically ask me. Xavier, hi, hi. Tahir Mirza, आपकी age currently 13 years old. Techno coders, have you solved Singage? No, I haven't solved Singage. आयान फिल्टर भाई 12th की फिजिक्स कैसे पढ़ें उसका फर्स्ट पार्ट नहीं समझ नहीं आ रहा है और 12th के फिजिक्स का फर्स्ट पार्ट आई एस्यूम it is about electromagnetism, right? So there's electromagnetism and there's electromagnetic waves, if I remember correctly, as of the last chapter. तो वो EM waves या तो last chapter है या फिर second part का first chapter है. So it's basically कि वहाँ 12th की physics, to be very honest, बहुत ही basic है. Now if you consider NCERT, so it is really very basic thing. And वहाँ पे जो maths use है, that it is not so advanced level of mathematics really. It is just some basic calculus, like you just need some derivatives and integrals, really basic ones, and that is all algebra and some trigonometry, right? तो यहाँ पे इसमें दिक्कत कहाँ आती है? Well, there might be difficulties in physical concepts. Now, physical concepts you might not be able to visualize it, right? So you need to be able to visualize it, and there are so many things in familiar reality. क्योंकि आपको समझना है कि maths के equations physical reality को explain कर रहे हैं. So here, any mathematical equation that you come across, let's say that it is about torque on a particular dipole in a given electric field, तब यहाँ पे आपको समझना है वो इक्वेशन क्या आपको बताना चाह रहा है. The direction of the constant electric field and that it is not aligned with the electric field. तब इस पे टॉर्क एक्ट कर रहे हैं. क्यों कर रहे हैं? क्योंकि दो साइड्स पे ये डाइपोल पुल हो रहा है, and as it is being pulled on both the sides and it is being pulled equally, what it tells you, what the equation tells you, is कि although ये equally pull हो रहे हैं, net force zero and net torque इसलिए नहीं zero because there is a line of action here, and that is why here you have a kind of this kind of torque on this particular object, and that is what basically this formula is telling you. You might consider its potential energy. So you need to be able to understand that how this equation is actually explaining physical reality for you. And of course you have the Maxwell's equations, which basically explains the electrodynamics, which unifies all of electrodynamics into one. I've been working on this for the last 2 years and I've solved it. I'm writing a new theory on quantum gravity, which does unify relativity with QFT to some extent. Now, to some extent, so it is still quantum field theory, I suppose. Because yeah, yes, there have been theories that unify, not even theories, I would say, but there have been some renormalizations in certain places, and so, but it isn't a really quantum theory of gravity if it cannot properly renormalize this quantum gravity, I would say. But maybe you have done it. In that case, I would like to know what this theory is about. Uh, here is uh, Shubhradeep Lahiri, 28. I have physics exam tomorrow. Can you briefly tell me about physics, please? Well, what do you want to know about physics? Well, if it's some question regarding physics, okay. But stream can I when you're not even very specific with what do you want me to tell you? Azitesh, bro, why electric field inside the conductor is zero? Well, electric field inside a conductor is zero because अगर आप Gauss law consider करते हो, so it is something like this. You have a conductor and it is a closed surface, and now इस कंडक्टर के सारे चार्जेस इसकी सरफेस पे आते हैं. दैट इज वन ऑफ द प्रॉपर्टीज ऑफ कंडक्टर्स. व्हाई डू दे कम टू surface? Well, that's a different point. So I assume that you know that it comes to the surface, and since सारे चार्जेस सरफेस पे होते हैं, अगर आप एक क्लोज्ड गॉसियन सरफेस कंसिडर करोगे inside inside this conductor, so that gaussian surface clearly doesn't have any चार्जेस इनसाइड. तो यहाँ का जो इलेक्ट्रिक फ्लक्स होगा, सो द क्लोज्ड सरफेस इंटीग्रल ऑफ इलेक्ट्रिक फील्ड, ये जीरो होगा. एंड इफ द क्लोज सरफेस ऑफ इंटीग्रल फील्ड और द इलेक्ट्रिक फ्लक्स इज जीरो, इसके अंदर की इलेक्ट्रिक फील्ड भी जीरो होगी. सो हियर यू कैन सी दैट सिंस सारे चार्जेस सरफेस पे एंड देयर इज नो चार्ज इनसाइड द कंडक्टर, यहाँ पे द इलेक्ट्रिक फील्ड इनसाइड द कंडक्टर जीरो होगा. Reza need how to start physics first time from which chapter? Well, it largely depends why you want to learn physics, and are you doing it for some sort of examination viewpoint, or maybe it's your academics, it's pure interest. So, if you can uh, be more specific about it, so I could possibly tell. The scientifics that I have also been working on Young Mills and mass gap. By the way, what's your research interest? Well, I haven't been involved particularly in research yet, but if I would say so, quantum gravity, as you said, it's like the holy grail of theoretical physics, as every physicist would call it. So, but that is still a distant dream as of now. If I were to work on anything, I would say that this thing about quantum fluctuations isn't really that well resolved yet. So that I would say quantum fluctuations is something that I would like to work on, because I believe यहाँ पे एक mystery है कि क्या quantum fluctuations में जो particles होते हैं क्या actual में energy borrow कर सकते हैं from the vacuum or from wherever from this universe. Are they able to borrow the energy and return it within time t that is given by the energy time uncertainty principle? Because I have seen lots of a difference in opinions of different people. So some claim no, quantum physics doesn't license the violation of energy conservation. Some claim that yes, energy conservation is being violated, and they are borrowing energy. But where is this energy coming from? Energy just can't appear out of nowhere. And if it can appear out of nowhere, so again, it's energy conservation, which I don't really think is happening. It's one of my favorite topics of physics. It's one of my favorite principles of physics, so I might be a little biased towards it. But I think that the time symmetry of the universe, of course, implies energy conservation itself. And that this, if the time symmetry is implying energy conservation itself, I don't think that there is such a thing that you could basically have laws of physics different one day than the other day. Because if energy conservation is being violated, then particles, or then the universe is being broken of its time symmetry, right? So how is it that you're actually violating the time symmetry as well? So I don't think that's happening. So, but maybe it is happening. We oftentimes come across quantum mechanics across things that we know doesn't come off as this much of common sense or what we have experienced in our everyday life. So the scientific said you and me could research on that together someday. Sure, would like to. Shamshad Hussain, how to define quantum theory in simple words? Well, there have been various formulations of quantum mechanics, and if you just want me to define quantum theory, I would say it is the theory of small objects. Like small objects, you have subatomic particles. तो यहाँ पे ये जो सब एटॉमिक पार्टिकल्स हैं इनकी थियोरी एंड ये नॉर्मल क्लासिकल फिजिक्स के लॉज के साथ बेसिकली नॉर्मल क्लासिकल फिजिक्स के लॉज से एक्सप्लेन नहीं हो सकते हैं. सो यू नीड अ न्यू थियोरी, अ न्यू मैकेनिक्स फॉर देम. That is quantum theory. And it began with Planck's search for a quantum of light in 1900, the paper that he published, where he showed that light की जो energy होती है ये certain bundles में emit होती है. And from there on, things progressed with things like uncertainty principle, and we found out that things on the very small scale do not behave. They really don't behave on as of very large scale. How does High's field make symmetry break? All things. Well, I'm sorry, I don't know about that. Well, if the term written is correct, I don't know about that. What do you know about lambda in general theory of relativity? It is the biggest blunder of Einstein, Xavier. Um, well, lambda in the general theory of relativity represents what is called the cosmological constant. Now, the cosmological constant is such that when Einstein wrote out his equations, तो उन्हें पता चला कि these equations really make no sense as of how it was written as of that time. And then he puts in a certain constant, this cosmological constant, to make his equations make sense. And the thing is that later he takes them out again. He takes them out क्योंकि उन्हें पता चला that the universe is expanding and ये सारी चीजें and all these new phenomena regarding general relativity and cosmos was being discovered. But then he realizes it was his biggest blunder of his life. It was as he called it. But the thing is, later on, we realized that cosmological constant, it was actually a blunder to take cosmological constant out of the equations. Because cosmological constant represents what we now call dark energy. So, although he called it his biggest blunder, but it was not such a blunder. Rather, it represents dark energy. JD Brawl stars, a concave mirror can have infinite poles and principal axes, so it should form infinite images which are different from each other of a single object. Well, I don't think that implies infinite images of a single object which are different from each other. Because here you see, if you study how the rays have been passing, this definitely implies that you're going to have a single object formed for a single image formed for a single object. Now they point like particles से start कर देते हैं. Here is a point and you trace its ray and it comes somewhere over here. Then there is the point next to it. Let's say for a certain height, you can trace the ray and it comes here, and you can trace the ray, and you find that there is this image that is being formed, and it is a single image. Magical gamer, please explain de Broglie's hypothesis. Thanks. Well, de Broglie's hypothesis is such that उन्होंने बताया कि जो मैटर है या जो पार्टिकल्स हैं, लेट्स से दे हैव अ सर्टेन मोमेंटम, तो यहाँ पे ये जो अगर कोई भी particle and you assign them a certain momentum, so what he told was that you can assign them a wavelength as well, which is related to the momentum. And how can you assign them a wavelength? Because he told that in quantum mechanics, जो पार्टिकल्स हैं वो वेव की तरह बिहेव कर सकते हैं, दे आर बिहेविंग लाइक वेव्स, यू हैव टू अंडरस्टैंड, दे आर बिहेविंग लाइक वेव्स, एंड इफ यू सी देम एज पार्टिकल्स, दे आर बिहेविंग एज पार्टिकल्स. तो यहाँ पे एक चीज जो कि बहुत कंफ्यूजन होता है कि आर दे रियली वेव्स? वेल, जो थिंग आप एज पार्टिकल्स ऑब्जर्व कर रहे हो, इवन व्हेन यू आर नॉट ऑब्जर्विंग देम, इवन व्हेन यू आर नॉट ऑब्जर्विंग इट, it is a particle. It behaves like a web when you are not observing it. So that is one thing that people often come in. That is the most important thing that you have to understand. And जैसे ही अगर ये वेव की बिहेव करता है, तो इसके पास एक वेवलेंथ इससे असाइन किया जा सकता है. That is the Planck's constant, the original Planck's constant, divided by the momentum of the particle. So I actually have a full video about this. You can just search my last third or fourth video. I suppose my last third last video, मेरा इसी के बारे में था कि how this de Broglie hypothesis isn't quite right. It isn't completely right, so to say. मतलब de Broglie hypothesis, of course, one of the greatest achievements of quantum mechanics. But one thing that people often, that it is the exact wavelength, it's like it's not. You have to understand that there is a lot of, you see, confusion that arises in it. So you can watch that video and fill up the necessary concept with that. And there was something, Ayush Singh, few words on Edward Witten. Well, Edward Witten, I would say he's, of course, he's the only physicist to actually receive a Fields Medal. So that's quite an achievement. I am in no position to state few words on Edward Witten, but I would say that, of course, as he has, whatever things he has done have been really great intellectual achievements, and he is the person who unified all the different interpretations of string theory into one single, that is the M theory. He has a Fields Medal, so that is, he has big achievements in mathematics as well. So he is, of course, I would say, the smartest, one of the smartest person on earth right now. Resonate, what is wormhole? Well, wormhole or Einstein-Rosen bridge, it is something like this. It is something like this, कि आप किन्हीं भी दो पॉइंट्स को, स्पेस इज कर्व्ड इन प्रेजेंस ऑफ मास, तो किन्हीं भी दो पॉइंट्स को कनेक्ट कर सकते हो इन स्पेस टाइम बाय कर्विंग स्पेस टाइम इनफ. You curve space time and you can connect these 2 points, so that even though there is a very long straight line distance between the two, indeed, lekin you curve the space time enough and you can just take like a shortcut bridge between the 2 points and you can just go there, and that is a wormhole. So you can connect different points in space time, in space and in time, and you can just take a shortcut. That's what a wormhole is about. So it's of course a complicated concept indeed. We haven't observed a wormhole, we haven't really created a wormhole or anything such, but we know it exists. Mukesh Kumar, how to start from class 6 to crack IIT and gain more knowledge in physics? Well, I wouldn't recommend studying for IITs when you are in class 6, really. Studying for IITs wouldn't be so much of use when you are in class 6. Mr. Shane, what is your age? Well, 13 years old right now. Science guy, why is there something rather than nothing? Physics answer. So I would say, what do you even mean by something, or what do you even mean by nothing? So that's indeed a little philosophy, I suppose. But you see, as the universe was created, uh, if I suppose, and almost everyone supposes, that the total energy of the universe must be zero. And why must it be zero? Well, it's because the universe has, if it has to be created out of nothing, and that's what the current physical models assume. then you can basically find that the initial energy of the universe, which is zero, should be equal to its current energy, which should be, of course, zero. So, to say that there is something rather than nothing, if you look at the very big scale, the total energy of the universe is zero. So there is nothing indeed. So the things are still the same as they were, and there is nothing so wrong or nothing so peculiar as we assume it to be about that. Because the total energy is still the same, and the laws of physics are being followed, right? Energy conservation is being followed. So the universe has done nothing wrong, or space time has done, or whatever, whoever has done nothing wrong and still followed and obeyed the laws of physics at the creation of the universe. So that is, it may just have happened. Now it isn't so peculiar, I mean. And the thing is, but why is it even happening? So it is something like quantum fluctuation. Well, we don't know. And as long as we are not able to trace back things back before the Big Bang, or at least at the Big Bang, we may not know, of course. So for that, you need a quantum theory of gravity. Um, Rad God, tell me, why can't we measure one-way speed of light? And now that is indeed a very good question. कि हम लोग speed of light, actual में it is one fact that you can't measure the speed of light. No, you can't measure the speed of light, and specifically speaking, one way speed of light. Now the question is that, does light travel at the same speed in all directions? Well, you haven't measured it experimentally. You have only measured it for two ways, because when you try to measure it, the one way speed of light, you come across many difficulties. And what are those difficulties? Well, it's like uh, if you have light going from this point to this point, how do you measure speed? Well, a constant speed, you have distance divided by time. But how do you know what is the time that light takes to go from this point to this point? Well, you have to be at both the points, which you can't. So you have one person at this point and one person at that point. And when he sends out the light signal, and you know it is a certain distance apart, and the time it you have recorded, you see, you can take a clock and you record a certain period of time, and you divide by that distance, you divide the distance by that time, and you find speed. But the problem is, how do you know when did he actually send out the light beam? So the thing is, you can't, and you can't have the information that he has sent out the light beam faster than speed of light. So there is lot of, you see, concept of simultaneity in this. And if you study special relativity, if you understand it, you'll find that it is not so easy to calculate the one way speed of light. You can only do it as if it's going forward, it returns, it may be. Maxwell's equations again tell you that it is of course same in all the directions according to Maxwell's equations, and that is what we have to assume. And may I hope that may in future it is possible for us to actually measure that the speed of light is indeed same in all the directions. From where have you learned all class 11, 12 topics, Abhinav, Aswin? Well, I read lots of books on 11th and 12th. Like I studied at Sivarma, I studied all the DC Pandey. I studied Resnick, Halliday, Walker. Then I went for university physics, as far as I remember. And I did some problems, not all, but some problems from Erodo, and some, you see, I was a little interested in problem solving. So I did some past year questions of JE main, JE advanced, though not all of advanced, mainly mains, as I did back then. Mr. Shane, I'm 17, a science biology student, how to become a physicist. I hate very much knowledge about physics. Well, if you hate physics or if you hate knowledge of physics, why do you even want to be a physicist? I wonder. Rath God, lovely answer. Thank you. Will you give J mean advanced in future? Well, I hope I'll give. So as of now, I haven't been preparing for J main or J advanced, but I hope I'll give. Sweet Cuba, who is your inspiration? Well, there have been lots of scientists who have been my inspiration, who have been very influential to me. And I would say there's Sir Isaac Newton, you have Albert Einstein, of course, Galileo or Maxwell, you have Roger Penrose as of current times, if you speak. So, among the living physicists, I guess if there is a single physicist if who I consider in the highest regard, so that's Sir Roger Penrose. Mr. Shane, Nikola Tesla best. Well, Nikola Tesla wasn't a physicist, and I'm talking about physicists here. Sarthak Khatale, what is a IQ? Well, I really don't know. Nakul Yadav, are you preparing for any competitive exams? Well, no, I'm not preparing for any competitive exams. And Jay Bharat, is there a singular, all-encompassing, coherent theoretical framework of physics that fully explains and links together all physical aspects of the universe? Please answer, Sarim. Well, there supposedly is like the quantum theory of gravity to say it, or the theory of everything. So there has to be a theory that at least unifies general relativity and quantum mechanics and explains them both by a single framework. So that is what quantum gravity is about. It is a little different, like it might be considered as a subset of the theory of everything if it exists. So there might not be any theory of everything, but yeah, there is a quantum theory of gravity which we haven't discovered yet. Okay. um that was Mr. Shane. Have लिखा था मैंने, hate नहीं. I love physics. Okay, so I definitely misread that. Couldn't look at it properly from this distance. So you have very much knowledge of physics, and तब उसमें you are 17 years old and you are a science biology student. But the thing is, you are a biology student, so I guess you it would be more preferable to choose maths, because if you choose maths, then you can gain more knowledge of physics and you can study it better. And regarding the knowledge of your physics, you mentioned it depends again at what level you have knowledge of physics. So I suppose you are either in 11th standard or 12th standard. So let me suppose as 11th standard. So it depends what level of knowledge you really have. Even if you say a lot, what level of knowledge you really have, what are your fields of interest. Now, how do you become a physicist? Well, you basically have to enroll in a university through the, you see, the process by which we become physicists. You have to enroll yourself in a university in a certain, let's say in a BSc course, you do an MSc, you do a PhD, and then you can apply for professorship. What about IISER, Mr. Shane? Well, of course, IISER is one of the best colleges, institutes for scientific research in India. So you have IICR, you have IISc. These are, of course, very great colleges indeed, and you can enroll yourself in any of their programs for BSc. And let's say then you have an MSc, and then you go for a PhD. Sarthak suggests some books for classical mechanics. Well, depends on what level of classical mechanics. So if it's just introductory. So a textbook, if you say, I would say introductory classical mechanics, Resnick Halliday Crane covers it very nicely. Abhinav Aswin. So it is possible to understand every theory just by reading from books. I'm 2024 J aspirant. Please guide me, Sarim. Well, regarding theories and stuff, yes, it is possible. Now, it might be a little difficult, and some people claim like it's not possible. You need coaching institutes and all that. It's like, no, you don't need coaching institutes or anything. It is possible. Like, it is possible to understand everything to even regarding problem solving, I can say it is possible to crack it just from reading books. You have internet and all this, so it is indeed possible. Jay Bharat. Saram, could you please explain about neutrino physics and standard model of neutrino? Well, if you want me to really go in the depth explaining it using standard model, then I can't really do it that way. I could tell you about neutrino maybe, but to actually explain this thing using the standard model would be really difficult thing, and I myself don't understand the quantum field theory yet. That's the standard model of of particle physics. So about the neutrino particle, it is something like this, that they're supposedly very light particles, and ye hamesha they're passing through us. They're passing through us every second or every milli or microsecond that you could possibly imagine, without even interacting with us. They barely interact with matter. They barely interact with matter. They're very light. That's what a neutrino is. Raj God, could you please explain Higgs boson, God particle? Well, God particle, Higgs boson. Now, here, one thing that you have to understand that's very important, that Higgs boson people often confuse with, again, spirituality and all this stuff, but it's like, no, it's not. And why is it called the God particle? Well, it's called the God particle because the field, that's Higgs field. Higgs field provides every certain particle. You have an electron, you have a quark, or whatever subatomic particle you could possibly have, and indeed not all of them, some of them, and I'll be telling you shortly why, or at least how it the Higgs field provides them with their masses. So since it provides them with their masses in popular media, it was popularized as the God particle. So it is providing them with their existence. It's like, no, it doesn't provide them with their existence, it provides them their masses. And the God particle is not the particle, is not what provides them their masses, it's the Higgs field that provides it. What's the Higgs boson? Well, every particle in quantum field theory in the standard model is a standing wave in the respective fields. So the Higgs boson, if you consider, it's a wave is basically a disturbance when you disturb the Higgs field. Well, when you disturb the Higgs field, you create a wave in it. And if you disturb it well enough and you can create a standing wave on that, well, that's a particle created then. So actually disturbing the Higgs field, you can create a particle out of the Higgs field. And what's that particle called? Well, it's called Higgs boson. That's what the Higgs boson is about. Sarthak Hatale, best books for physics except H.C. Verma. Well, again, you can be a little more specific that how you want to learn or what level of physics you want to learn. So I could maybe tell you about some books apart from H.C. Verma. अथर्वा विशाल भाई 19 का टेबल सुनाओ. I don't know 19 का table. Why no such things when there's just calculator? G. Bharat Sarim, is it true that quantum gravity admits a lower dimensional description that does not contain gravity? Well, yeah, it does not contain gravity because it is not renormalizable to call it for gravity, you see. That is the reason quantum field theory or quantum mechanics, you see, is not complete. And here you have actually written quantum gravity. So that confuses me because quantum gravity or quantum theory of gravity is a theory that unifies quantum field theory and gravity and general relativity. So in that case, it should be rather quantum mechanics because quantum gravity is a theory yet to be discovered. So as of the current models, the standard model, it does not have gravity to it. So you cannot explain gravity using the current models, at least the quantum models, you see. So you have general relativity for that. Now you need such a theory, of course, for further developments in physics, and that is what the quantum gravity quest is about. Rath God, what are your whips on higher dimensions? By the way, again, lovely answer. Well, thank you. My whips on higher dimensions, well, higher dimensions, as told by string theory, is not something I very much believe. So, so here, if you consider higher dimensions, I do believe in dimensions as introduced by Einstein's relativity. So you have time as a dimension. But the thing is, I think there might be higher dimensions, but it's not very much how M theory or string theory says. So might be or might be not. But I think the current physical models do explain things well in the current dimensions that exist, and there seems to be no need for any higher dimensions unless you have string theory, which is not provable. Um, Here was a question. Sagar studies capacitor and inductor relation. Well, there is not a very, you see, exclusive or explicit relation between a capacitor or inductor, uh, or to be more precise, a capacitance and an inductance. So the thing is that a capacitance or a capacitor is basically a device where you can store charges. So you are storing charges on the plates of the capacitor to call it. An inductor is something, it works very much like a resistor. So a resistor opposes the current flowing through it. An inductor, on the other hand, it opposes the change in current that occurs. So the change in current, very similar to resistance, but the change in current, the two of them can be put together. And when you put the two of them together, so it's a really interesting thing that happens right there. What you'll find is oscillation in the values of charges and currents. And why is that? Well, it occurs for this reason, that when the current enters and it starts, the charges start, you see, uh, they start gathering on the plates, and you are basically collecting charges on the plates of the capacitors. And as you're collecting charges on the plates of capacitors, of course the current decreases, of course. And when the current decreases, you find the inductor indeed tries to oppose it, but then you find that there is an oscillation that occurs in the value of current. And why is there an oscillation? Well, it's like this, that when the charges are gathering on the surface or on the plates of the capacitor, after some time you again find yourself seeing that the charges have to leave that once they have gathered. Of course, if you don't take resistance into account, they must leave the place again. And when they leave again, now where do they go? Once they have been stored in the electric field for the last time, they now need to be stored in the magnetic field of the capacitor, of the inductor, because the inductor has magnetic field to it. Because as the current changes, you see a change in current in the inductor will cause certain magnetic field to be created, and that magnetic field is created. And you see that in fact electric current itself creates magnetic field. So it's not necessarily the change in current that only creates magnetic field. And this is why you find an oscillation in the values of currents and charges. So it is a very interesting thing to be studied in depth indeed. One physics, how gravity influences the time. Please explain. Well, gravity is caused by the curvature of space time. So, the curvature of space and the curvature of time. So, it is indeed very basic that when you go in regions of high gravity, you're basically going in regions where space and where time has been curved more. And where it has been curved more, you find yourself seeing that, of course, time must slow down. The rate of the flow of time must slow down. So, that is the relation between higher gravity and time. Sweet Cuber, how much time do you take to cover a normal chapter? Well, a normal chapter of what? Like when I was studying Resnick Halliday Crane and all. When I was studying Resnick Halliday Crane, which was the last general physics textbook that I did, and I was basically doing one or two chapters a day from that. And I remember I completed the entire textbook in like how much time? Resnick Halliday Crane. No. It was 20 days something. Yes, it was 20 days something. So I had covered some chapters before that, but that was so I was really quick on that. When I was with HC Verma, it was a lot of time because that was the first physics textbook that I picked. So again, it matters with my previous level of expertise. These days, I'm doing quantum mechanics, and it is taking a lot of time because you see that the thing is the mathematics of quantum mechanics isn't really that difficult. Like I will say, now there are lengthy problems. That's a different thing, but there are lengthy problems, but the difficulty, well, it isn't that difficult really. The conceptual problems that arise when you're doing quantum mechanics is really twisting your brain. So that definitely takes a lot of time. Learning with Akhil, age, well, 13 years old. Archana Lavangare, black hole information paradox. Well, the problem is that when you throw something in a black hole, well, of course, you're not really throwing it, but when something falls in a black hole, so information basically falls inside a black hole. And since it's a singularity deep down there where the laws of physics are being broken down, the general theory of relativity doesn't work. You find yourself seeing that the center of the black hole or the insides of the black hole is disconnected from the outer universe and everything. So the information that you threw in there, where did the information go? That is the black hole's information paradox. That whether this information cannot be destroyed in physics. So what happens to the information inside that? That is what we don't know yet. Binav Kumar, why quantum mechanics and relativity don't work together? Well, quantum mechanics and special relativity do work together, not in the general non relativistic form. You have the Schrodinger equation, which is the equation of quantum wave mechanics. So it's like the Schrodinger equation is a non-relativistic equation. So non-relativistic quantum mechanics studied on the basis of Schrodinger equation or Heisenberg's matrix mechanics is indeed not uh, does not contain relativistic effects to itself. But you can have the Dirac equation, for instance, and the Dirac equation is a relativistic equation. The thing is that you can have relativistic quantum mechanics, but that is only containing special relativity to it. So it's something like you can combine special relativity and quantum mechanics together, and you can have relativistic quantum mechanics. And indeed, quantum field theory is a unification of quantum mechanics, classical field theories, and special relativity. It's the general theory of relativity that doesn't fit into the idea. And it's like the general theory of relativity, which explains gravity. And you cannot really renormalize gravity. We say it. in quantum mechanics, and that's the problem. What is renormalization? Well, it's a way of getting rid of the infinities. In non-relativistic quantum mechanics, for instance, what we do is normalization. So what is normalization? Well, this is normalization is something that if you want a certain function, and it's called a wave function, to explain the behavior of a system, of an object, a quantum object. So you need that wave function, and you need that wave function to be such that when you take the, it's a complex number by the way, when you take the square of the absolute value of the wave function and you integrate it from the negative to positive infinity, it should come equal to 1. That is what normalization in non-relativistic quantum mechanics is about. And why should it be? Because this thing, the integral over space of the square of modulus of wave function, gives you the probability of finding the particle in any particular place. So if it's between 2 points A and B, so it's the probability of finding the particle between the points A and B. If it is between 0 and whatever A naught, is the probability of finding the particle between 0 and A naught, if you carry out the integral in that. If you don't carry out a definite integral, if you carry out an indefinite integral, so it's just the integral of square of mod psi, that is how you represent the wave function, dx is the probability of finding the particle between x and dx. So you're basically getting a function between x and dx. Now since the particle, if it exists, has to exist somewhere, and it has to exist somewhere, and the probability that it exists in space should be 1, right? Because it has to exist somewhere. So if you carry out this integral from negative to positive infinity, the result should be 1, and this is normalization. And if a wave function doesn't, in its uh, special, or in its you see, natural form, doesn't follow this, what you can still do is that as long as it gives you a finite result, no matter what result, it doesn't give you one, you multiply that function with a certain constant, the so-called normalization constant. And when you multiply that and you work out the normalization constant, you can have that, you can work out this constant, find yourself that you can create such a wave function that is normalized. This very same thing in relativistic quantum mechanics is renormalization, getting rid of infinities that you have. Because if the integral is itself infinite without the normalization constant, or with the normalization constant, well, it's not real. And so renormalization or normalization is a way to get rid of infinities, and it is not possible for gravity. That is what the problem is with relativity and quantum mechanics. Learning with Akhil, how you maintain consistency? Well, it's all just a matter of interest. The more you learn, the more you're interested in it. That's it. There was this question: the World Guide, JE or research? Well, research I would prefer. An aspirant, would you give any tip to have enough courage to pick up new books and complete it without thinking that it's extra and not needed? Well, why I study is just for the sake of my interest in physics. So I basically pick up what I like to read, whatever I want to study, what I want to learn at any specific moment of time. And again, it is a strategized though. It is really strategized, but I am still really learning just for the sake of learning itself, just wanting to learn more and understand things better. So but still regarding that, I could possibly say that you should be able to start small, like start small enough that you can achieve, that you can achieve it, that you can complete it. You should start small enough, but you should also start big enough that it will be considered an achievement. So in between, I would say. Sweet Cuber, does light have weight? Well, weight is something very exclusive to the body. It is around, so it is on the moon or the sun. So it would be better indeed to ask if light has mass, and light does not have mass. Fun physics, what is EPR paradox? Explain. Well, EPR paradox or Einstein-Podolsky-Rosen paradox, it's something like it's about basically entanglement. You see that let's say you have in 1935 paper, Einstein, Podolsky, and Rosen, they questioned regarding this about this what we call EPR paradox, and then the topic of the paper was, can the quantum mechanical description of reality be considered complete? And they really said that it cannot be considered complete, even though we can still think that things as of 1935 were not really so complete in quantum mechanics. And if you have basically two particles that are interacting from a certain time to a certain time, and they're interacting with each other, and they are interacting only with each other, and what you do is then they're separated, they interact and then they are separated. So when they interacted or when they were one part, you could say you could explain them using a single wave function. And when they separate, you say, well, now one particle is here, one particle is here. If you still take that wave function and you perform one measurement on one particle, since it is connected to that particle, you suddenly find that the wave function collapses for the other particle as well. And how is it possible? Well, if it is really far, is the effect instantaneous? So this concept of entanglement that you find is really very peculiar. So the thing is that this, how is it possible that you're transmitting information faster than light? If you measure spin of one particle, it comes to be up, and you know that the other particle had spin down. You immediately know that the other particle has a spin down. So how is it possible that you can basically transmit information faster than speed of light when special relativity doesn't allow it? And indeed, many persons do believe that it is possible to basically process or to send information faster than light in quantum entanglement, whereas it is not. It is possible to break the entanglement faster than light. That is what happens, because as you make a measurement on one particle, the entanglement immediately breaks. That's what it's about. So the faster than light thing that is happening here is not information reaching from one point to other. So this is what many people indeed confuse with is the violation of special relativity. There is no violation of special relativity here. An aspirant, do you watch anime or cartoon? If not, what do you watch for the sake of enjoying? Well, like I used to be really obsessed with anime. Like I guess roughly 6 months ago, right? So it was like roughly 6 months, and I was really obsessed with anime. And to tell you the truth, I have watched it like in a very short span of time. I have watched around 80 anime series. But right now I'm not so obsessed with anime. Like I still watch sometimes. I just before the live streaming, I was indeed watching an anime episode, and I think Classroom of the Elite, even one of my favorite shows, had just third season first episode yesterday only. But the thing is that I just watch it for the sake of recreation. As of now, I was really obsessed back then, but as of now I consider, yeah, it's good for recreation when I'm really bored. Like I've been studying, I was studying all this day, I was trying to study, I was learning quantum mechanics, figuring this thing out and that thing out, and bored. So when I'm really bored and I don't have any other brain cells to invest in quantum mechanics, what do I do? Well, in that case, you just entertain yourself with something, some recreation. So that's it about. I sometimes watch anime or some other shows, but it's all about recreation. That's what it should be. An aspirant, do you watch it? Dr. Stone is really amazing. Well, that has been one of my favorite shows, and that is, I believe that every science lover should indeed watch once, because you do learn a lot of things from that. And I watched that. Uh, the world guide. Who is your favorite physics scientist? Well, my favorite physicist, I would say, was Isaac Newton. Isaac Newton, I would say. And so, Mara, bhai, please tell me how to be a prodigy like you. Well, and the thing is that you have to do what you're interested in. So um, it's like a kind of natural intelligence or a god gift that you say. No, it's really something very difficult to talk about, whether you are not naturally gifted with something with special abilities to understand electromagnetic fields or to be able to solve Maxwell's equations. So it's like, I think we all have our special innate abilities. Now that is what I believe, that yes, someone might have some mathematical intelligence, some natural mathematical intelligence higher than some other people. And that is, I believe that some people have a higher mathematical intelligence than other people. But the other person might have better musical intelligence than the first person, the former person. So the only way that you could progress most is that what you, and it often aligns, like the thing that you're interested in often aligns with the thing that you are good at. I mean, that is very natural thing indeed. So you should be doing what you believe is what you should do, what really fills your mind, and what is your curiosity, your point of curiosity, or your interest or your passion. That is what I believe. So that is how you could possibly be a prodigy. You just have to find at a very young age, you have to find what interests you the most, and you have to work. And the thing is, even though someone might have a little bit higher than average mathematical intelligence or whatsoever, you have to dedicate a lot of time into that. Without dedicating a lot of time and thought and studying, learning, reading, you cannot be one. Fun physics, how I study quantum mechanics. Well, you need lots of prerequisites for that. Like, you need to learn about classical mechanics. You just need classical mechanics. You can't do without that. You need to learn classical mechanics. You need to learn about electrodynamics, right? So electrodynamics is one very important point. So that's classical mechanics and electrodynamics, the wave theory. You need to know about waves and all, about how waves propagate and all these things. Thermodynamics, a little thermodynamics, I believe, is important in order to understand it. And and regarding, so this is something that you need to already know. If you're doing non-relativistic quantum mechanics, I would say still, even during non-relativistic quantum mechanics, some knowledge about special relativity definitely helps. I would say, like, it makes you understand the concepts better. And after that, you have the mathematical prerequisites, the basic calculus 1, 2, and 3 that you must have already learned if you're doing these topics, I assume. So you have calculus, you have the multivariable calculus and vector calculus, and differential equations, ordinary and partial. You don't need to be an expert on partial differential equations, but ordinary and partial, need to learn them, and some cookbook recipes for solving differential equations. And there's then this field that helps very much indeed in solving or in learning quantum mechanics, and that's linear algebra. So if we learn linear algebra, then it's like it will definitely help a lot with notations and with actual learning of quantum mechanics. You'll be able to learn it better. Glow Eyes Gaming, bro, I'm seeing a 2 year old video, and in this video, you solved JE advanced paper. How? Well, 2 years old, I don't believe I was completely able to solve JE advanced questions, but yeah, I was indeed able to solve lots of JE advanced questions, and it all just came with practice and learning. Like, I've been learning physics, passionate, curious about physics for like 3 years, for 3 whole years, and I've been studying it continuously. Like, it's like every single day I've been studying for 3 whole years. So if you study for 2 years this way, you crack IITJ and whatever. And you see that I've been also passionate about it. So it's not that I'm just learning for the sake of some examination. I've been passionate about it, and I'm learning the mathematics required to do anything, or I'm learning all the prerequisites for any theory that I want to learn. And it's all about consistency. I've been consistently learning it, all of it. That is what I've been doing. Fun physics. If I learn all classical mechanics, then I start quantum mechanics. Well, the prerequisites that I mentioned definitely help. Like, or you might face lots of difficulties in doing quantum mechanics. Again, doing quantum mechanics, I'm very careful with this word, because when you say understand quantum mechanics, so you have Richard Feynman claiming that I think I can safely say nobody understands quantum mechanics. And you have Niels Bohr. If anyone says that they understand quantum mechanics, they are either a fool or a liar. So to do quantum mechanics, well, you need to know these prerequisites. The world guide. Why you like physics? Why not maths? Well, I think maths is too abstract. I believe maths is too abstract, and it's like physics actually explains reality, and I want to understand reality. I want to understand how reality works, how things really works. You have an apple falling, and why does it fall? Well, the question Newton asked it himself. Does the moon fall? How does it fall? So I like to explain reality using these models, and that is why I'm interested in physics, not maths. Though I like maths, of course. You can't have otherwise. You can't study physics otherwise. Checo, bro, people claim ancient Indian science was ahead. How far do you think it's true? Well, honestly, I feel now it's a little annoying, honestly, when people claim all these theories had been discovered and mentioned in ancient Indian texts. Now, I am not really trying to defame any of the things. I'm in no position to. But to actually claim that everything just came out of India is just bizarre, right? So, and I've been saying that people claim that gravity was first discovered in India. Well, everyone knew about gravity even before Newton. Everyone did. Everyone knew that the Earth attracts every object that falls or whatever. But Newton was the first that actually gave the mathematical formulation and described what gravity is, or described how it acts, even though he didn't tell the mechanism behind it. And Einstein was the one to do that. And there have been lots of such claims that Indians discovered this and that. And many of these claims, some of these claims might be true, but most, I suppose, are false. And I think it's annoying, really. All right, so I'll again have another live streaming where we can discuss more um, questions, topics regarding physics and all this stuff. So maybe next, whenever I'll be sure to post to spread the information ahead. But that was all for today's stream, I suppose. And thanks to all of us. Bye. Good night.